I'm going to be taking a look at transforming the sine wave to create the equation of a function. So here is the sine wave, and I am going to try to transform the sine wave given this function. Now, it seems like a pretty daunting task to get the equation of the red function, but it's not that bad. So we must know what we mean by amplitude and horizontal axis. These two ideas really help us out. So now I'm going to just give a brief review. Here's the transformed form of a function. Y is equal to A, where A is going to be a vertical stretch or compression. In trigonometry, we call this amplitude. B is the horizontal compression or stretch. In transformations, we call it wave compression. C is a horizontal shift. In trigonometry, we call it a phase shift. D is a vertical shift. In trigonometry, it is going to be very helpful to recognize that this is the horizontal axis. So allow me to graph to pick out some things from our graphs. Here, we're going to start off with our black, and we're going to try to transform the red. So really, these two ideas of amplitude and horizontal axis give us what we need for our vertical transformations. In previous units, what we've done is we followed the order of operations for transformations A, B, C, D. Here I'm going to do it a little bit differently because it's going to be easier on me. I'm going to do all of the vertical transformations first. So to pick out what the vertical transformations of amplitude and vertical shift, I'm just going to draw some guidelines for me. This is I've drawn the maximum and the minimum. So for instance, our amplitude, if we can recognize this equation, our amplitude is 5 minus -1 divided by 2. 5 minus -1 is 6 divided by 2, so our amplitude is 3. So that implies that the A value is 3. Now our horizontal axis is going to be that line that cuts this red wave exactly in half. So from a transformation point of view, if you go back to the regular sine wave, the regular sine wave had a horizontal axis of 0, the x-axis. So how do I move that all the way up there? Well, it's going to be through a vertical shift. So allow me to demonstrate what this might look like in transformations. I'm going to change my A value to be 3. There we are. I'm going to shift my wave up. Now this is almost in the right place. I'm pretty happy about this. But to shift my wave up exactly 2 units. And by shifting it up 2 units, you can make the argument that in fact what you're doing is you're shifting up that horizontal axis. So the way to control the middle of the wave is through a vertical shift. Now, I'm half done taking care of all of my vertical transformations. The next 2 transformations, one of them is going to be quite difficult. But it's not the next one. So sine is not my favorite function to transform, but it's cosine, by the way, in case you're curious and keeping tabs at home. But if we want to get the transformation B, the horizontal compression, really, let's ask ourselves 2 questions. I'm going to get rid of the red wave. what is the period of y is equal to 2 sine x plus 2, the black wave? The period is 2 pi. I always find it most beneficial to measure a period, the wavelength, as from crest to crest, and that is 2 pi. It goes from, the crest occurs at pi over 2, and this is 5 pi over 2. If you go from here 0 to 2 pi, what you have to recognize is that it intercepts our horizontal axis at 0. The function's increasing, but it intercepts it again, but the function's decreasing, but here it intercepts it again, but my function's increasing. So that's a nice way that you can pick out the period. So if our period is 2 pi, how do we make it? Well, here, what's our period? That's a great question I ask myself. The period of the red curve goes from 0 to pi, or 0 to pi. So the red curve has a period of pi, black curve has a period of 2 pi. So how can we move the black curve so that the period changes from 2 pi to pi? Well, we compress it by a factor of 2. In other words, if we make b equal to 2, there we have it. So in other words, the compressed equation will be y is equal to 3 sine, open brackets, 2, open brackets, x minus 0 plus 2. I'm not going to discuss the hardest transformation here, and that's the horizontal shift. But as you could well imagine, all we have to do is move the wave left and right to match up our equation.